So let's understand why do we need yet another algorithm to detect objects in video. So the goal of YOLO is, so humans, as you know, they can detect objects very easily. So in fact, it's a second nature for us. We are able to drive vehicles very easily and recognize cars around us, objects around us very easily. But the goal here is to teach computers to detect objects. That's the main goal. So let's understand what are the challenges with the current algorithms, right? So if you typically take a look, we have existing algorithms. So let's go through that and their speed. Let's understand those algorithms. So we have algorithms like let's say deformity parts model version 5. It can detect uh, 0.07 frames per second, and that means in an entire image, if it has to detect an object, it will take about 14 seconds per image. Okay. Then later on, another version came into picture, which is called a regional CNN, which is a bit faster. It can detect about little bit slower, not faster, 0.0 frames per second, and it takes about 20 seconds to detect an image, right? So this is not good enough for a self-driving car, right? Because let's say a self-driving car usually driving at a speed of 60 miles per hour on a freeway, right? This speed to detect objects, 14 seconds and 20 seconds is not good enough. So let's say if you use the RCN algorithm in a self-driving car, so to detect an object at about to see an object, and from the time it sees an object to detect the object, whether it's a human or another car, it takes 20 seconds. But that time, so in 20 seconds, the car would have already traveled about 1/3 of mile, right? So which is equivalent to 1760 feet. Let me change the pen. 1760 feet. So this is not good enough, right? Because on a typical highway, the distance between the adjacent car is probably less than 10 feet. So the chances of collision is very high. So that's why we need an algorithm which can detect the objects very fast, right? So later on, few more algorithms came like fast RCNN. So it can detect about 0.5 frames per second, and it takes about 2 seconds, or faster RCN, it takes about with 2 seconds per image with fast RCN, right? Which is still slow because it still goes up to 15 to 20 feet. So it's better, but it's still not good enough. But if you use YOLO, right? So YOLO can detect the speed of the YOLO is 45 frames per second. It can process, right? And it can identify objects within 22 millisecond per image. Okay, per image, right? Yeah. So that means if you translate this to a distance, YOLO can detect objects within 2 feet of distance. Like by the time the car travels 2 feet, it already recognizes the object. So that's why YOLO, because of this speed, it makes it's an ideal choice for using it in real time object detection video, and like self-driving car or even movies, to identify the celebrities in movies in real time. So that's the advantage of using YOLO. Another advantage of using YOLO is YOLO looks at the whole image, whereas RCNN looks at only the parts of the image. So YOLO can understand the whole global context of the image, and it can also understand how the objects in the image are correlated to each other. So here is a summary of various models. So for each model, it shows the mean average precision using Pascal and also the speed. So if you look at the earlier models like DPMB5, accuracy and speed. So if you compare like with DPMB5, RCNN, faster CNN, as you can see, YOLO really stands out because of its high processing speed. It can process about 45 frames per second, and it can detect objects in image within 22 milliseconds. So this makes YOLO an ideal object to use in real-time object detection use cases without sacrificing a lot of accuracy. So its mean average precision about 69.0, which is not too bad, and the developers are continuously working to improve the accuracy. YOLO also generalizes very well on artwork too. So here you can see in the image on the top row, when we apply the YOLO algorithm on the artwork, it can still able to generalize and identify the objects within the artwork also. And also the bottom row shows the real-time object detection. It does typically a good job, but in some cases, like in the second image in the bottom row, it misclassifies a person as an aeroplane. So the improvement has been continuously made, but it works pretty well for most of the cases. So that's why YOLO is very, very popular these days.